sort of what you're looking at in the computational method, not the algorithmic method, although it will be an algorithm and you are quite welcome to use this if the other one is too difficult for you. Up to you. I'll explain what I'm talking about shortly. But let's go and take a look at how the computer would handle the very same problem. We did have two. Let's see if I can get the other one up. There we go. So this is important. We can't change the length of array, so we can't declare a new array because it's static. I'm going to sort of get rid of that for the time being. Let's change the data item to 12 again. That's what I'm looking for. And I'm going to index these as I did in the previous one. So I'm going to keep the right hand side there so that you can use it as a comparison. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now the way that the computer plays around with it is it's never ever going to change this array. This array is going to stay there. In this one, we discarded that half of the array. Then we discarded that half of the array. And then we discarded that half of the... We're never going to do that. We're always going to have the same length of an array. Now that means we can't use this. Because if I always try to work out the length of the array, I'm always going to end up with 5. That's not going to give me my middle point. So the big change that I'm going to do, first of all, is I'm going to use kind of markers. I'm going to say where the start of my array is. So I'm going to put S there for start, and I'm going to put E on the end here. So I know where the start of my array is at 0, and I know where the end of my array is at 9. Now, I can use len data to find this value. So if you remember, if we did len data, oops, let me just put it down here, len of the data, so it's the length of this list, is going to give me the value 10 to begin with. And actually 10 is outside, so I really need to subtract 1 from that. So if I do 10 minus 1, then I get 9, and that is my end point. So in a program, I could start this off by saying that start equals 0 and E equals, the end equals that code. So that would find the two values, my start and end. Okay, so let's go through it. I'm going to delete this for the time being. We'll come back to that later. Let's put some space in here. The first thing I need to do is work out the midpoint. Now, I really need you to have focused well in maths, because if I've got an interval of any two numbers, so let's say I've got the numbers 17 and 25, and I'm going to put those in round brackets because I'm kind of talking maths now. If I want to find out the midpoint of an interval, remember we're doing this because we can't just work on the length of the list as it changes. We need to find the midpoint of an interval. So to find the midpoint of an interval, all I really need to do is add these two numbers together and divide by 2. So if I do 17 plus 25, that gives me the grand total of 42, I think. And if I then divide that by 2 to find the middle, that gives me the value 21. So that's the midpoint of an interval. Let me just check that out, so I don't want to sort of run you down the wrong path with my maths. So let's just check that. So if I do 17 plus 25, and then let's put that in brackets. So there's another little bit of maths for you. This is BidMaths coming in. Do this first before you divide. 21. There you go. So that's the way to find the midpoint of an interval. So why am I saying that? Okay, well, I've got my start and end here. Now my start is 0. So really what I'm trying to do is find the midpoint of the start and end. So if I put my start in, which is 0, and I put my end in, which is 9, remember what the equation was. I add them together. So 0 plus 9, that equals 9. And now I divide that by 2, but dividing by 2 as an integer, well, it should give me 4.5, but remember we just knock off the 0.5 and we end up with 4. So I've got my midpoint, 4. And what I'm going to do is check if my value at 4 is 12. So let's take a look at it. At 4, it's 16. It's not. 12 is less than 16. So I need this half of the list, the 0, 1, 2, 3. So what I'm going to do is move my end point. So instead of being all the way up here, I'm going to move my end point down to where the 4 is and then take 1 off it. Oops. So it's actually above the 3. So in effect, I've discarded this part of the list, the 0 to 9. And then I can perform exactly the same equation. So I need to find the midpoint of between the start and the end. So the start is 0, the end is 3. Add them together, so 3 plus 0 equals 3. Divide that by 2 into integer division. That gives me 1.5, which gives me 1 as an integer. So that's my next index that I'm looking at. So I'm going to check the value at 1. So I check the value at 1, and it is 6. Well, 12 is greater than 6, so I really need this half of the list. So I'm going to move my start because I need to change this half. I'm discarding this half, so I really need to move my S from there. Let's see if I can do that. To now I had position 1, so I'm going to add 1 to it. So it's now at position 2. So my start is going to move to there. It's difficult putting the spaces in. So that's my start moved. There we go. Sorry about that. So I'm moving these two markers, the start and end, depending on the list. And I can keep going through checking for the midpoint. So the midpoint of these two, so I'm on 2 and 3. Don't forget, we're not finding the midpoint of these numbers. We're finding the midpoint of the indices. So I've got 2 and 3, so I need to find the midpoint of the start and end. I can replace the start with 2, and I can replace the end with 3. So I'm going to add those two numbers together. So that is 2 plus 3, which equals 5. Then perform my integer division to find the midpoint. 5 divided by 2 is 2.5. That's not an integer. I need to take off the 0.5. So I'm looking at position 2. So if I now take a look at position 2, to check to see whether it is 12. So at position 2, I've got 9. I think I've made a slight mistake there, but I don't think it really matters. I think the start and end point are going to be the same one. Check it's 9. We're looking for 12. It's bigger. So I've got to move the start point across 1. This is the mistake that I've made. There we go. So I've moved the start across 1, the end doesn't move, and they're exactly in the same position now. So if I check the midpoint of these two, so the midpoint of start, which is 3, and end, which is 3. So by adding those together, 3 plus 3 is 6. 6 divided by 2 is 3. If I check my data at position 3 for the value 12, I have found it. Also, because the start and end have met, if I didn't find 12, I could then say, well, I haven't found it in my list at all. So that's the different method. I am not writing down a new array each time. In the next video, I'm going to write down how that start and end changed as I looked for it, so that you've got a comparison to this side for your method. But this side is not computational, it's algorithmic. This side is computational. We can actually write this into the computer, which is what we're going to do to get our binary search working. So in the next video, I'm just going to lay this out in steps, just in case you want to learn this method of showing it. And it doesn't matter in the exam if you're asked to do it. Personally, I might learn this version, because then I've learned not only the algorithmic way of doing it, but also the computational method. But it doesn't really matter. It's up to you. And we'll deal with that when we come to revision and plenty of practice. So the next video, I'm going to put this in the same way that I did that. And the only reason why I didn't in this one is because I wanted to show you that the array did not change. It remained the same all the way through. Only this S and E changed. In other words, this was static. It didn't move. It didn't change, didn't grow, didn't shrink, and I didn't need to declare any more variables. So on to the next video then.